Hello. My name is Chris Baines, and I'm the TL of the Client UI Android team at Twitter.
My name is Nacho, Nacho López, and I work in his team.
So we're here today to talk to you about how we have embraced Jetpack Compose in the Twitter for Android app over the past kind of 2 years or so. Now, in April this year, we worked with Google on what we called a developer story, and it highlighted some of the benefits and benefits and positives that we've seen since adopting Jetpack Compose. We've shipped a number of features over the past kind of 18 months as well, all implemented in Jetpack Compose. So communities was the kind of big one, and that was our first. Then we had Twitter Circle, which is the UI, and then there's been a new navigation drawer implementation which rolled out last month, which is all in Compose. And there's more in development too. Now, after the developer story, we had a number of teams at kind of other companies reach out to us, and they were interested in hearing how we adopted Compose. So not really about the implementation side of it, it's more about kind of all the other stuff that you need to do. So migrating to a new tech is kind of at the implementation levels, like one thing, but actually doing that across a large app and a large engineering team, and with different product priorities and all the rest of it, and that's a whole different thing that you need to think about when adopting new technology. So in this talk, we'll cover kind of how we did that at Twitter. So before we go into what we did, I think it's important to call out that what we did wasn't perfect. Like, it was our journey, and we learned a lot over the past 18 months. So that is to say that your journey will probably be different. Do what makes sense for your apps, your teams, your product priorities, all the rest of it. And when you think back to how you adopted Kotlin, the same kind of story will kind of apply. You'll have to do the same kind of things. Right, so let's get started talking about our journey. So Twitter for Android is a large app. Currently, we just have over 1,000 modules, or greater modules, of various sizes and complexity. And just like all apps that evolve over time, it's about 12 years old now, the code base, there's large amounts of legacy code in there. Now, of those 1,000 modules, roughly 300 contain some kind of UI, so about a third of them. And all of those modules are owned by just over 30 teams, each focused on their own feature or part of the app. Now, 30 may sound like a lot, but most of the teams are quite small. Like, in terms of mobile engineers, there might be one or two. So back in late 2020, our organization posed a question, which was, how do we make UI development faster? And specifically, how do we increase the velocity of our feature teams so they can ship their features faster, whilst also trying to maintain or even increase quality? So that question very quickly became, how do we actually migrate to Compose? So this was before Compose 1.0, but it was obviously going to become the future of Android development, and that has actually played out, where you can see how many Compose talks there are at this conference. And similarly, the iOS team were doing something similar. For Swift UI, they were going for the same thing. So we decided to start with a single component. In our case, that was the button. We decided on the button because it was something that our design team had recently redesigned. It's also quite prolific. Like, most screens will have a button of some kind. And so it was a nice, simple component which had far-reaching, kind of what was used everywhere. But when you start using Compose, you can't just go straight into writing a component. You've got to start thinking about your theming and styling. And from there, everything flows. So we, like many companies nowadays, have a custom design system, well, our own design system, called Horizon. And this system provides a set of defined colors, components, typography, size, lots of other tokens. Now, the important thing to say is that it doesn't map one-to-one material. It's fairly close in some instances, but in other ways, it's very, very different. So our next question became, how do we implement our design system in Compose? So when you think about Compose, you might think of it as like this single thing that you're going to adopt. But actually, it's made up of a number of layered libraries. So at the base layer is the runtime libraries, and they provide kind of fundamental APIs for Compose, but they're not specific to UI at all. So think snapshot system, state, that kind of stuff. Next layer is UI, and as the name suggests, it's where UI starts coming into play. Now, these are UI primitives, so think touch, layout, measure, that kind of stuff, but not components, really. Layer above that is foundation, and that's where kind of design system agnostic components come in. So think box, lazy column, lazy row, lazy layout, which we spoke about yesterday. Anything that's kind of design system agnostic. And then finally, we have the material layers. Now, this layer provides the opinionated implementation of material and also material-free. Now, I want to stress a word there, which is opinionated. The material library for Compose is built as a material library, and it has all the guidelines, the material guidelines baked into it. There is no generic theming system or styling system in Compose as such. The one that's in material is built for material. So if we kind of compare this to views, and if you kind of squint, it's kind of similar in terms of layering. You have the framework, and the view system, app-compat, and then MDC. But if you actually compare which layers contain like bits of material, it's quite different. In the view side of it, it's very leaky. Materials spread everywhere. But on Compose, it's very, very specific, and it's only in the material library for Compose. And this was no mistake. The Compose team put a lot of effort into creating those kind of strict layering in there. Now, this is great, but it does have some knock-on effects for apps. So if you think of a design system as like a ratio from 0 to material, most apps with their own design system will want to be somewhere in the middle. It doesn't have to be the exact middle, but they'll want to incorporate some parts of material. And that's to maintain platform consistency. You want your Android app to look like an Android app. There's no getting away from the fact that material is the default theme on Android. So think things like touch highlights, like ripples or whatever. Generally, the app Chrome, elevation, it could be any parts of it really, but most design systems will want to incorporate parts of it so that your app doesn't look completely different to any other app on a user's phone. Now, if you think about ease of implementation, the kind of extremes are much easier in Compose. Like if you're not material and you don't care about material at all, it's much easier. You just build your components on top of Foundation, you skip all the material libraries, and job's done. And then if you're fully material, again, it's much easier now, because the material libraries are very much baked and built for material, so actually using them is super easy. But if you're in the middle, it's kind of a bit easier in views. So that leakiness we were talking about earlier means that you can very easily pick out bits by not having to kind of bring in any of the material libraries. Like touch highlight is there as a theme attribute in the view system. Now, to get most of these in Compose, you're going to have to probably use material and then use material theme, which means that your design system, you're going to have to map it to material in some ways to try and get all that automatic behavior. So when you start implementing your theming, you're going to have a decision to make. You either map your design system to material, or you start afresh using Foundation. Now, to give you an idea about what we did, we started out with material. So we wrapped all of our components, so our button wrapped the material button and all the rest of it. And that's really good. It's a really good way to start because it allows you to iterate very fast, very quickly. And you know that the implementations underneath are well tested and actually work. But what we're finding now is that some of the kind of rules in material conflict with our design system. And it's kind of tripping our developers up. So what we're doing now is copying out the material implementations, which are usually quite simple. It sounds daunting, but it's actually quite simple. And then copying it into our code base and then making our adjustments as we need. So fast forward now to kind of April last year, and Compose was just about to hit 1.0. Now we had implemented most of our theming and kind of like base infra. And so now we started thinking about like, how do we actually start using Compose in apps? Well, it went from how do we start using Compose to how do we actually start shipping this and letting feature teams use it. So we decided to create an early access program within the Android team. We found 4 teams who were eager to use Compose, and we were going to start writing some kind of new UI. So we started small in terms of teams, as it allowed our team to really give one-to-one direct kind of help and feedback to these teams. And the program was very informal, which was kind of, when we're looking back now, is probably a bit of a mistake, because it wasn't very clear about what the responsibilities are from us, but also what the expectations were from those teams. But the idea was that each team was really motivated enough to want to use Compose, and it worked out pretty well in the end. Now, in terms of how we chose each team was about to start writing some kind of new UI, and each of the teams had different requirements. So some needed lists, some needed text input, some needed emoji, some needed bottom sheets. It acted as a very good way to kind of crowdsource our requirements and what we needed to ship as fast as possible. But we quickly found out that supporting 4 teams kind of concurrently in such like quite close coordination was just a lot of work. We were providing in-depth feedback on code reviews, design docs. As people started tripping up on certain kind of topics or APIs, we'd end up writing docs. And then also trying to fill feature gaps, as we said earlier. So as our EAP teams started merging Compose UIs, other teams started taking notice. They began using Compose without kind of us knowing about it. And the first we'd usually hear about it is when they either hit an issue or they basically ask for a code review request. Now, as we didn't know about it at the time, basically what it means is it just completely destroyed that sprint or whatever we're working on at the time, because we'd have to drop everything and prioritize and try and help them. And usually it's because the teams weren't quite ready in some ways to use Compose. They didn't have like a long-term plan in place. It was mostly just a developer who was really eager to use it, which is great, but long-term it doesn't quite work that well. So as you can imagine, there come a point in time when supporting loads and loads of teams continuously just overwhelmed us. The animation is a bit of an exaggeration, but hopefully it illustrates the point. Like, it just comes to a point where we just got, well, it's just a lot of work. So fast forward now to about December last year, and our main priority was just how do we spend less time supporting. So we come up with two ideas. The first was a bit defensive. It's what we call an allow list. So quite simply, it's just a list of Gradle modules which are allowed to use Compose. We didn't want to be gatekeepy, but allowed us to slow down kind of this organic adoption to a point where we could actually help people and actually make it sustainable. Teams could request to be added to the allow list. And it wasn't like a super in-depth request. We'll talk about it in a minute. But it allows us to just get a bit more control over it all. And the biggest thing is that it enabled us to set expectations about what we could provide in terms of support, but also what those teams needed. If there was something which we know that Compose couldn't support, like at the time accessibility was a little bit shaky, we could tell them and make sure that actually they knew about that before they even wrote any code. So the mechanics of the allow list is pretty simple. It's just a text file that's checked into the source tree. Just contains a list of Gradle modules, and then there's some Gradle code which basically checks if the Compose is being used, and if that module isn't in the list, then it throws an exception and the build fails. So the allow list was pretty simple. The request is pretty simple. There's 4 questions. Can you spend the time to actually learn Compose? Like, Compose is a mind shift change. You can't really take all the stuff you know from views and then apply it to Compose as such. Like, you've got to really change your mental model and actually think about it. If you can't spend the time, it's probably not going to succeed. Like, do you have the time to iterate on our feedback? Like, if we're going to spend the time reviewing all your code, design docs, blah, 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 you want to make sure that actually you're going to listen to us. Like, what features do you need? If there's stuff that isn't going to work, we'll tell you. And also, is your whole team on board? We don't want to be, as in my team, doesn't want to be responsible for reviewing your code for the end of time. You want to bring people along with you and actually spread the knowledge and making sure that your team is sustainable going forward. So we go forward now to June this year. So at that point, we actually got rid of the allow list. We built all the kind of necessary infra and docs and all the rest of it, and stuff that Nacho is going to talk about in a minute. And we felt confident that any team could succeed at actually using Compose. So we removed the allow list, and anyone could use it. At this point, we still wanted to keep some kind of, well, not control, but we wanted to still keep an eye on stuff. So we created a program called the Shepherds program. And this was, in a simple case, it's just that it's a group of engineers which are there to kind of spread and help shepherd adoption of Compose throughout the team. This group is automatically added to all code reviews. Now, we don't expect these group of people to review every code review that goes past, but it allows people to keep an eye on things, and also if you see a new team starting to use Compose, you might pay a bit more attention to their code. And finally, the goal is that we actually expand the Shepherds group beyond just our team. Like, we want to actually, as people start using Compose and they become experts, like they become proficient in it, we want to actually spread this and add those people into the Shepherds group, so actually it becomes a much wider team. So when we get to what we're at today, we now have roughly 90 modules using Compose. which you think back, it was about 300 UI modules, so we're about a third the way through. There's over 20 teams using Compose right now, with more trying it out as we go. So again, it's about 2/3 of the engineering teams we have. Now I'm going to hand over to Nacho to talk more about how we actually got this to work.
Thank you, Chris. So what I'm going to be talking about today is the developer experience of what it is to use Compose at Twitter. As Chris was saying, Twitter for Android is like a really big app, and also the code base is very long-lived. And because it's very long-lived, it has a lot of custom infra that accumulated through the years. And a lot of this custom infra has been created before there was even a viable open source alternative to it, like think databases like before Room, etc. Because we have a lot of custom infra, I'm going to talk about like 2 concrete examples. One is like we have a UI framework, internal UI framework called Weaver that manages 2 things: two-way data binding and view models that not use the Android architecture one, so they can use in JVM projects, etc. That are built on top of MBI. Well, MBI is built on top of them. And we have also a DI framework fully featured that's called Scythe. It's being worked on since like 4 years ago. You can think of it as like Hilt meets Anvil meets object-oriented programming principles. It's very interesting. So, of course, because we have this custom infrastructure, we have to give support to it in Compose, especially like if you are exposing some state through your view model, like it needs to be ultimately rendering Compose. So you have to create this custom infrastructure. The same thing happens with our DI framework. We have a bunch of infrastructure on top of Compose to support that, to be able to acquire objects from it. So the thing is, like, Google already provides magnificent documentation for Compose. So of course, like the first thing that our documentation has is like links to all the Google like Rockstar documentation. Especially the pathways are amazing. But because like we have this custom infrastructure, we also have to provide how to use that. And this is infrastructure as used outside of Compose. So we have to onboard people that know how to use it to Compose. So speaking of documentation, you have different archetypes of people that are going to be consuming it, right? Like you have like new developers that have joined the company, they want to get a start in Compose, but you also have like people like with longer tenures and like maybe they are senior people, but they don't know anything about Compose because they haven't interacted with it yet. So you kind of have to cater the documentation thinking on all the levels and all the archetypes that you're going to find. So for example, for people starting to use Compose, independently of seniority level, we found a great value in creating code labs. So for example, we have one that teaches you how to create a new screen using Compose in our app. So you create the DI setup for it using Scythe or DI library. Then you create the view models using our custom infra project Weaver. And then you build a whole screen using Compose UI based on that. So it's like an end-to-end, like you can complete it in 20 minutes. But it has been like really useful to get people a kickstart. But when you're in the head of it, like you're in the head of it, like you're writing composables left and right, you're likely going to hit some walls. So we want folks to know that we got their backs. So we also have some part of the documentation dedicated to listing out the pain points that we encountered, or just like if there is any blocker, like no, you shouldn't use Compose for this. Like we tell them. And for example, things that we found is like we use custom emojis all over our app, and that's not feasible right now. Also, like whenever you're using a Compose view or an abstract Compose view child inside of a recycler view, there are some considerations to have. If you use it like for tiny composables or whatever, like it is going to be painful and your performance is going to be worse. Also, complex accessibility experiences are more limited in Compose versus what you can do with a view system. And there are others, but it's a live document. So every time that we, as Chris said, like we have many teams using Compose, every time that they find some issue and they tell us, like we document it if there's no way out, right? So when you start working on Compose, up until it starts to click for you, there is a steep learning curve. So ideally, you would want some guidance on how to make things properly from the start. That's when documents about like best practices, style guides, etc., come very handy. But because we're all in the process of learning here, Compose is like fairly new in comparison with a view system. How can we start writing these documents at this time, right? We have to come up with ways of addressing the common issues that you're going to find, etc. So we will going to circle back to this, but in our case, we got there with tooling. So documentation was a big investment for us during the road to general adoption in our app. As Chris mentioned, it happened in June this year. An even bigger investment for us was to get people onboarded faster. And for that, tooling plus developing extensions for the infrastructures were key. So we used a bunch of different tools for this. For example, I'm going to start talking about Compose previews. So previews are very helpful. They allow you to see what you're doing with your code, and they are especially useful whenever you're like starting from zero in Compose, because you get to see what you are going to render. So in our app, we maintain 3 different themes, which is standard, lights out, and dim. And we would like these themes to be supported in previews at no extra effort, right? So we define them with an enum. That's like not super important. But you can create preview parameters providers to like support that. And you can use them with an annotation at preview parameter in preview composables to be able to like create automatically 3 different variants of that preview that use every single one of those themes. But the thing is, like, only one of these preview parameters are allowed at the same time. So we had to create like a tiny workaround. I've linked there. It's like a very tiny piece of code. We call it composite preview provider. But what that basically gives you is the opportunity to use a pair or a tuple or whatever to add more stuff in there, and generates combinations of all your themes plus like the different other things that you would get from other preview parameters providers, and render all of them. So you get all of them like at the same time at very little effort. Let's talk a little bit about how previews work when you use a lot of custom infra, like I mentioned that we do. So previews, they run in their own activity. You don't control it. It's a very bare bones activity, right? So for example, these are a couple of examples of the custom composables that we use that are tied to our infra. We don't want them to crash, but why would they crash? Well, like most of them have close ties to our DI system. We kind of make assumptions on what base activity or fragment they are going to be using, and this is how they work, right? Like, but we have to keep them from crashing, because like we have an extraneous activity that's going to run our composables, and these composables are tied to our infrastructure in this way. So we kind of treat them as tests. So we create fakes for them. And you can check this composition local called local inspection mode. And if it's set to true, you know that you are in a preview, right? And that allows you to do to provide defaults that are sensible for your app if this is set. So for example, this snippet is how we choose which font to render in the app in our composables. And this is basically what you would, like the code path that you would take. It has like this font feature class. This is actually checking through the AI which feature flags are enabled, and if it's enabled, it's going to choose that font family. Otherwise, it's going to go with the default one, right? And this was crashing our previews because it was hitting the AI, and the AI wasn't there. So with this, with local inspection mode, we're able to detect this, and we're able to provide it to you before the feature flag is even set. So you can provide like the defaults or the best cases scenario or the treatment or whatever that you want, and give it directly. For an even faster feedback loop, we've been using live edit as much as possible lately. In the past, we've been hyped by similar approaches, but they usually, none of them work for us in Twitter for Android. So, however, the silver linings here is that live edit is showing a lot of promise. It mostly works, and it's a little bit crashy sometimes, but mostly works, and it's getting better all the time. So we are hopeful that this is going to be the way forward, and it's going to be the way of like writing fast, composable code. Another thing I wanted to bring up is like a feature parity with views. It's not quite there yet, getting close by every version. But luckily, we have Android View. It's our lifesaver. So a couple slides ago, I was talking about like the gotchas and the things that we would flag if you're trying to use Compose. So some of those problems can be actually addressed if you use an Android View fallback. But using Android views, especially when you're starting working with Compose, it kind of seems like admitting defeat. You want to do it everything composable, everything by the book. So it's like an easy exit that you don't want to take. However, in some cases, it's really necessary to use it right now. So for example, these are like a couple of examples of things that we had to use Android View for, using custom emoji in text, using custom emoji as well in text fields, but also media embeds, so for example, in DMs that you can paste a screenshot or whatever. And also for interoperability with your tweet view, as you can imagine in the Twitter app, tweet view is kind of a big deal. Basically, everything is a timeline and everything has tweets around. So we are rewriting tweet view in Compose right now, but it's going to be a slow process. But for now, if you want to render a tweet, you have to use Android View and set up on top of it. So if we take a closer look on text, the custom emoji support is not there yet, but it's really important for us. We have our own open source collection that's called Emoji. Like other apps are using it, Discord, etc. And they are used everywhere in our app, so we have to support it in like text field, etc. So what we did is we created a facade for the text composable. And to know what to use, whether the Android View, where the Android View version or the text composable version, we decide via heuristics. So basically, if the string we detected has an emoji, like, OK, that has to go through Android View, else it can use the text composable. But you also can like choose to force the wrapper, for example, in DMs in the text field. You don't need to write like an emoji or something. But if you want media embeds, even if you're not writing emoji, you have to go through that. You can always use the original as a fallback. And this facade uses a very similar API to the text composable. So the idea here, like the long-term plan, is to swap them once the text composable has like support for everything that we need. So drink. So Jim, according to his Twitter bio, I'm not going to argue, is a father of Compose. He says that, so yeah, it must be true. He always says that it usually takes a bunch of months to get people to a good spot, right? And up until then, like it's an uphill battle. The learning curve is very steep, etc. It requires your mental model to change, as we were talking before. So we kind of found the same situation when onboarding people to use Compose, because not everybody is starting at the same page. And it is very easy to make mistakes that are very sneaky and easy to spot. Like, not easy to spot at all. So at the beginning, it was our team, the client UI team, that was taking care of all the code reviews that had any Compose code in them. Our team is, at that time, it was 6 engineers, 7 now, and it amounted to 15 hours of review time per week per person, which is a lot. And the first reviews were like total, absolute carnage. It was like lots of comments, lots of byte shedding. Like you would see a patch, like it had like 50 comments. A lot of the things that people were doing wrong mostly is like people that were trying, like they weren't working in a declarative way at all, and it took them like some time to get adjusted. And also we were finding potential bugs and code that wasn't recomposition friendly, etc. And this gave us like a good perspective on the common issues, because everybody was like falling in the same traps. But as you can imagine, bike shedding gets like really annoying very fast, and the uptime time that you repeat the same thing to a different person, you just don't have it in you to provide the explanation, like the really good explanation again. So as you might imagine, this wasn't sustainable at all. So we went all in creating static checks for this. And they proved to be the best return of investment for our team. They scale really well because it's not you, it's a machine that's like checking everything. So even if you have like 100 developers like onboarding to Compose at the same time, it will catch it all. The 20-second time that you repeat something, you're not going to be very articulate. You won't be in a teaching mindset, to put it lightly. You can do a really solid job, like providing like good error messages and linking them to the documentation for extra contents, and use this as an opportunity to teach people on how things should be done. For that, we use a little bit of lint, but mostly in our case it was KT-lint. Tiny disclaimer here is that KT-lint worked really well for us at Twitter, and we were, because like mostly we were already using it, and we had already custom rules for like things like DI, etc. However, detect, lint, even a custom IntelliJ plugin, like it would give you the same result. Because like you say, you have the same access to the code base, you have the ST nodes, PSI elements, KT files, etc. And porting custom rules from one to the other is very easy. It's the same kind of code. As to why KT-lint worked really well for us, well, allows for custom rules, has auto fixes, and lint has been historically breaking a lot with our app. Like every AGP update usually takes it down, and we recently spent like a month with it deactivated for all of our feature modules because it was crashing our builds. KT-lint is really fast, so you can like run it in a pre-commit Git hook, and it has like a unofficial though, but it has like a really good IDE plugin. So I tweeted about this approach a bunch of months ago. I think it was in March. The other community seemed to like it, but many people asked us to open source it. Many people asked that for other things. So we took that to heart. We launched our rules for both detect and KT-lint. It's native. It's not detect using KT-lint under the hood or anything like that. And we hope that it would ease the journey of other teams or companies in the community as well. And there are close to 20 rules right now there, and each rule points to a documentation with more context and why that is a violation, how to fix it, etc. I'm going to go over like some of those the principles behind like some of these rules and like put the spotlight in some specific ones. For example, hoisting. Hoisting is something that has been generally difficult for people in our team to understand, not in our team, like in our company, to understand in the beginning. So Compose is built in this idea of an unidirectional data flow, right? Like data state flows down, events flow up. And to implement that, Compose advocates for the pattern of hoisting the state upwards and enabling the majority of your composable functions to be stateless. So a good example of this is that we found it was very common that people toss around view models like willy-nilly. Like, they toss them around. This is not recommended because it usually means that the other composable that's receiving the view model, like, then it becomes stateful, which is exactly what we wanted to avoid. So instead, we can hoist the state once it's like you get the view model in some composable. We host the state there, send any events back via Lambda. So another common way to try to circumvent hoisting that we observed is that people were passing down mutable types. So this is not only conceptually fishy, it's that it is known to cause actual issues. So yeah, we detect that, we disallow that. Then another one that was like very common and very recurrent was like the implicit dependencies. So getting a composable to work, if you have implicit dependencies, it's difficult because it usually means that you either go and see exactly what this composable is doing inside of it, or you just try and fail, like runtime crashes, like, oh, this thing is missing, okay, I'm going to add it. Oh, this other thing is missing. Oh, 20 minutes building, good luck. So asking for people to delve into the internals of a composable, like to know what to use, that's not a nice thing. So if possible, we should make all of those dependencies explicit instead. So for example, view model acquisition. So we detect if a view model is called like in the middle of a composable, and we're like, no, put it in the signature. So this way, we can make the dependency explicit, and if you're writing tests, like, you're going to have an easier time, or even if you are using this composable, you're going to have an easier time if you want to provide a different view model, right? Like, so we prompt people to inject the view models as default parameters. But then we observe the same thing with the composables that we're hitting on DI and acquiring objects from DI. So we added a rule for that internally. But then, like, you can extrapolate that implicit dependencies should be made explicit in the signature, right? It's same as like you would use dependency injection like in a class. It's the same thing you do in a composable. Of course, you might be wondering, what about composition locals? Because they are the epitome of implicit dependencies, right? So we disallow them. So unless there's a really good reason for that, they can be added. So unless there's a good reason for that, we don't allow them. But like for app-wide infrastructure, there are some legit use cases where you would want them. So we also maintain an allow list with composition locals that we allow people to use. And it's our team deciding, like watching, like having a strong ownership of that allow list. So we get to see if it's like warranted or not. So Compose is highly performant due to its nature and its ability to just recompose the parts of UI that really change. However, there are like a bunch of things that you can easily get wrong, which ends up making recompositions happen more often than they should. So for example, like when using calling collection interfaces like list, set, and map, Compose compiler cannot infer if the underlying collection is actually mutable. So we prompt our developers to use Kotlin X immutable collections, and they are really helpful to mark immutability, and they are supported in Compose out of the box. Another alternative, if you really don't want to add like a new dependency for this, is like, yeah, you can create like an immutable wrapper around the list, which we don't recommend, but it will also work. Another subtle one is that if you are using a Lambda that references a variable from outside of it, Compose compiler won't be able to optimize and mark the composable as a stable. So if it's possible, we ask people to prefer using a method reference when dealing with lambdas that capture variables outside of their surrounding code. If this is not possible, you can always remember the lambda as code to the capture variable. We do this with an IntelliJ plugin that uses internally the reference lambda, like method reference lambda checking of IntelliJ, and like adding some heuristics on top of it. As for modifiers, they are the heart of Compose UI. They encapsulate this idea of composition over inheritance, allowing our developers to attach logic and behavior to layouts, and they're especially important for your public components. And they allow colors to customize the component to their wishes. Okay. So we detect that if they emit content, they should have a modifier, and if the modifier is used in multiple places, that's bad, because UI breaks in many ways. And there are many more. So we created our best practices around these rules. Then the error messages point to these best practices, create a nice feedback loop, we open source them. And there are still a couple of internal rules that we haven't shared because like, they don't make any sense of the company. But I'm going to speed run through this or not?
I think we're out of time.
Oh, OK. So TLDR, we use Roboelectric for testing, and we use the same for Compose. And to make sure that the UI is in a good state, we use Paparazzi. Hi, J-Rod. Paparazzi doesn't like Roboelectric, so we had to nuke it from the class path. We do some stuff on top, like we remove the transparent pixels, we add borders, and we set the local inspection mode to true. So same good things that we had on previews, Paparazzi can get advantage of. So yeah, that's basically like the gist of how using Compose at Twitter is. OK, so going to leave it like here.
All right, thank you very much.